We are starting this series from 2015 to 2025 of all papers of P1, variant 2. And now we are starting the paper 2015 May, June. This is paper 1, total marks 75. The timings for this paper is 1 hour 45 minutes. It is May, June, and now we are starting from this question number 1. These are the instructions which we have to follow. Question number 1 is the function f is such that f dash of x is equal to 5 minus 2x square and 3 and 5 is the point on the curve y is equal to f of x. Find the equation of this curve. So, f dash of x is equal to 5 minus 2x square and it is passing from this point 3 and 5, and you are going to find out f of x for this curve. So we know that if f dash of x is given, then you are going to integrate it to get the value of f of x. So we are integrating f dash of x, d of x is equal to integration of 5 minus 2x square into d of x. Because the limits are not given, but they have mentioned it that it is passing from this point 3 and 5. So we will find out the constant with this 3 and 5 condition there. So f dash of x after integration will become f of x, and that thing is equal to 5x minus 2x cube over 3 plus a constant of integration a there. But we know that y is equal to f of x there. So here y coordinate is equal to 5, and x coordinate is equal to 3 minus 2 by 3 into 3 cube plus constant of integration a. So this will become 5 is equal to 15 minus 2 into 27 over 3 plus a there. So 5 is equal to 15 minus 18 plus a there. Our a value will be equal to 5. This is minus 3. Go to the other side. It will become plus 3 there. So a value is equal to 8. So equation number 1 is going to say that f of x is equal to 5x minus 2 over 3 x cube plus constant of integration a. So this is the required equation of this f of x there. Now, question number 2. Question number 2. In the diagram, AYB is a semicircle with AB as a diameter, and OAXB is a sector of a circle with the center O and the radius R. Where angle AOB is equal to 2 theta radians, find an expression in terms of R and theta for the area of this shaded region. So they have mentioned this shape there, O A B. Where this is radius R, this is radius R. They have given it is equal to 2 theta radian. Then and this is the shaded region in that figure there, where this point is X and this point is Y. And you are going to find out the area of shaded region. We know that this is a semicircle from AB as a diameter. Let's say if we join this with this part, then this is the point C, which is the center of this AB. And let's say that is equal to, make an angle of 90 degree at this point. This 2 theta is going to be converted in the form of theta and theta there. So basically, if we can calculate the area of this shaded region, then it is the area of this semicircle minus area of this sector, which is OAXB, minus area of the triangle OAB. So this is our required area of the shaded region there. So first of all, the area of this semicircle is being calculated there. So we know that this O, A, and this C, this is making an angle of 90 degree. It is R, and this is angle theta there. And we know that this will become R sine of theta, and this will become R cos of theta there. So we have calculated this AC is R sine theta, and this circle AYB is a semicircle, so its radius is equal to R sine theta there. So this we can write it as R sine theta, and this is R cos theta. So it is basically this from center C, you are making this circle AYB. So area of this semicircle will be equal to half into pi into R sine theta whole square, because this is the radius of this semicircle there. So it is going to be equivalent to pi over 2 R square sine square theta. Let's say that is equation number 1. We can write it there. Now we are going to find out the area of this sector OABX. And we know that area of the sector OAXB is basically equal to half r square into theta. There is 2 theta. So it is half r square 2 theta. So that is going to be equivalent to r square theta, because 2 and 2, they are going to cancel out each other. Then the area of this triangle OAB, because it is the area of this and it is the area of this, two triangles are there. So we can combine these two, or we can directly use the sine rule there, because angle there is between the two lines OA and OB is 2 theta. So we can directly write this thing as half into r square into 2 theta. So area of triangle OAB is basically equal to twice the area of triangle OAC. This can be written as twice the area of the triangle OAC is half into base, that is r cos theta, and the height is r sin theta. So this is going to be equivalent to 2 into half r square into sin theta cos theta there. R, the total area of this triangle will be equal to, using these three, so shaded region area is equal to half pi r square sin square theta minus area of the sector, which is equal to r square theta minus area of the triangle, there is r square sin theta cos theta. So this is finally equal to half pi r square sin square theta minus r square theta plus r square sin theta into cos theta. So this is the required area of the shaded region of this part there. Now we are starting question number 3. Find the coefficient of x square and x cube in the expansion of 2 minus x power 6. Second part. Find the coefficient of x cube in the expansion of 3x plus 1 into 2 minus x power 6. No, we are finding coefficient of x square and x cube in the expansion of 2 minus x power 6. We know that for the term formula is equal to NCR a power n minus r into b power r. So we can use this formula for the expansion for the coefficient or the term. So we don't know where r x square and x cube will occur. So we will just write tr plus 1. N is there 6, cr as this. A is there 2, which is 6 minus r, and b there is minus x, and power r is there. R plus 1 is equal to 6cr into 2 power 6 minus r into minus 1 power r into x power r, which will be equal to 6cr into minus 1 power r, 2 power 6 minus r into x power r there. Now, since they are asking for x square coefficient, so you can write it here for x square. 2 should be equal to r, because x power is r here. So r is equal to what? 2. So when we put r is equal to 2, then 6c2 into minus 1 power 2 into 2 power 6 minus 2, that is equal to 4, into x square. So the coefficient of x square is basically equal to 6c2, that is 15, minus 1 power 2 is 1, into 2 power 4 is 16, and that thing is equal to 240. For x cube, then 3 should be equal to r. So we put r is equal to 3 in 1, then this will become 6c3 into minus 1 power 3 into 2 power 6 minus 3 into x power 3, and that thing is equal to 6c3 is known as to be 20 into minus 1 into 2 power 3 is 8 into x cube. So x cube coefficient is this. So that thing is equal to minus 160 is the coefficient of x cube in this expansion there. Now they are asking about the second part. Find the x cube in the expansion of 3x plus 1 into 2 minus x power 6. We know that they are asking for the x cube coefficient. So this means this 3x is going to be multiplied with the expansion of this 2 minus x power 6. So where x square will become, that is the coefficient of this part there. So coefficient of x is here 3, and x square coefficient we can find out in the second part, and that is going to be calculated equal to 240. Because directly we can use the word hence there. So 2 into this x cube will become 240 into 3, and then again this 1 is going to multiply with x cube there. So 1 multiplied by x cube coefficient is 160 there. So that thing is equal to 720 minus 160, and that thing is equal to 540. So this is the coefficient of x cube in this expansion. Or in other words, simply you can do what you will expand this 2 minus x power 6 and write it the all, and then you will check where it is x cube will occur. So that is going to be occurring in the value of 3x, and 1 is going to multiply with the x cube there. So directly we can use this concept here, that if we calculate this value of x square and then multiplied by 3x, it is going to give us the coefficient of x cube. Again, 1 is going to be multiplied with that value where x cube is there, and that x cube is coefficient of this expansion. For this 2 minus x power 6 is minus 160, so it should be multiplied by this, and it is directly giving you the coefficient of x cube there. Now we are starting question number 4. Question number 4 now. The variables u, x, and y are such that u is equal to 2x into y minus x, and x is plus 3y is equal to 12. Express u in terms of x, and hence find the stationary value of u there. So u is equal to 2x into y minus x. So u is equal to 2x into y minus x is equal, where x plus 3y is equal to 12. So x plus 3y is equal to 12, then 3y is equal to 12 minus x, or y is equal to 12 minus x over 3. So we put into this equation number 1. So u is equal to 2x into 12 minus x over 3 minus x there. This will become 2x into 12 minus x minus 3x over 3. This is going to be equal to 2 by 3x into 12 minus 4x. This will be equal to 2 by 3, 12x minus 4x square is u. So this is u in terms of x there in the first part of this. Then they are asking find the stationary value of u. We know that the stationary value, as u is a function of x now, so stationary value will become du by dx, and we put it equal to 0 for the stationary value. So du over dx is equal to 2 by 3 is a constant which is written outside as it is. 12x derivative is 12 minus 4x square derivative is minus 8x. And then you put it equal to 0. So 2 by 3 into 12 minus 8x is equal to 0, or 12 minus 8x is equal to 0, or x is equal to 12 by 8, and that is equal to 3 by 2. So now this is x value there, and you are finding the stationary value of it. So x is equal to 3 by 2 for this part. So u value will be equal to 2 by 3 12x minus 4x squared. So we can put the value of x into this and you can get the stationary point there. But they are just asking find the stationary value of u there, which is being calculated there, x is equal to 3 by 2. So for the stationary values of this, u is equal to 2 by 3 into 12 into x value is equal to 3 by 2 minus 4 into x square is 3 by 2 whole square. This will become 2 by 3, that is equal to 18 minus 4 into 9 by 4. So that thing is equal to 2 by 3 into 18 minus 9, that is equal to 2 by 3 into 9. 18 minus 9 is 9. So 3 threes are 9. So that is value is equal to 6. So u is equal to 6 for this value of the stationary value of this point there. Now we will start the next question. Question number 5. Prove the identity sine theta minus cos theta over sine theta plus cos theta is identical to tangent of theta minus 1 over tangent of theta plus 1. Hence, solve the equation sine theta minus cos theta over sine theta plus cos theta is equal to tangent theta over 6 for the interval from 0 to 180 degree there. Now we take the left hand side of this question number 1. Sine theta minus cos theta over sine theta plus cos theta. But if we look at the right hand side, it is tangent theta minus 1 over tangent theta plus 1. It means both sine and cos, they are being eliminated. But we know that tangent theta is basically equal to sine theta over cos theta. So if the left hand side is we divide on both sides by cos theta, then you can get this answer as sine theta over cos theta minus cos theta over cos theta whole divided by sine theta over cos theta plus cos theta over cos theta. This is going to be equivalent to tangent of theta minus 1 over tangent theta plus 1, and that is the right hand side of this expression there. So you have proved it that the left hand side is equal to what? The right hand side for this part 1 there. Now for the second part, sine theta minus cos theta over sine theta plus cos theta is equal to tangent theta over 6. But this left hand side is sin theta minus cos theta over sin theta plus cos theta. It is being proved equal to tangent theta minus 1 over tangent theta plus 1. So we can write this thing as tangent theta minus 1 over tangent theta plus 1, and that is equal to tangent theta over 6. Now you can cross multiply. This will become 6 tan theta minus 6 is equal to tangent theta into tangent theta plus 1. This will become 6 tan theta minus 6 is equal to tangent square theta plus tan theta. Now we shift the whole to the right hand side. So 0 is equal to tangent square theta plus tangent theta minus 6 tangent theta will become minus 5 tangent theta. Minus 6 is going to the other side. It will become plus 6, and that is equal to 0. Now, this is a quadratic equation, but in terms of what? Tangent theta. So we can suppose let tangent theta is equal to P. Then tangent square theta will become P square. So we substitute this into this equation number 1. So it will become P square minus 5P plus 6 is equal to 0. If we factorize this thing, it will be P square minus 2P minus 3P plus 6 equal to 0. P is common, P minus 2 minus 3 is common, P minus 2 equal to 0. Or it will become P minus 2 into P minus 3 equal to 0. Then P value will be equal to 2 and 3 there. But P itself equal to tangent theta, and that is equal to 2, and tangent theta is equal to 3. If theta is equal to tangent inverse of 2, then we can find out that tangent is positive in the first and the third quadrant. So third quadrant is not used because the range is from 0 to 180. So only it is positive in the first quadrant. So we can find out the value of tangent inverse of 2 there. So theta is equal to tangent inverse of 2 is equal to 63.4. So there is one value of this. Again, tangent theta is equal to 3. Then theta is equal to tangent inverse of 3. And that is also in the first quadrant. So 71.6. So these are the two specific values of theta, which is in the range of 0 to 180 of this expansion there. We are starting the next question. A tourist attraction in a city center is in a big vertical wheel on a circle on which the passengers can ride. The wheel turns in such a way that the height h meter of the passengers above the ground is given by the formula h is equal to 60 into 1 minus cos of t. In this formula, k is a constant, t is the time in minutes that elapsed since the passengers started the ride at ground level, and kt is the measured in the radians. Part 1. Find the greatest height of the passenger above the ground. On complete of the revolution of this wheel takes 30 minutes. Show that k is equal to 1 over 15 and 1 over 15 pi. Find the time for which the passengers is above the height of 90 meter. So this is the questions concerned with the cos function and cycle of that. Since this is question number 6, we know that the height of this function is given equal to 60 into 1 minus cos of t there. We know that from this, the cos function is basically have the graph like this. So it is from 1 till minus 1. That is the graph of cos of x there. Now they said in the first part that find the maximum height. When he is going to ride on this cycle there. So we know one thing, that this height can be used with the calculation there. Then it is making the maximum height. So it can be, the cos range is basically from minus 1 till 1 there. So it has the range from minus 1 till 1. So the cos value is equal to minus 1 and 1 there. But we know that cos is minus 1 when it has the maximum height, this part there. Our cos of x is equal to 1. So we have to calculate the maximum height there. So we will replace this cos of kt is equal to minus 1. So in this way, h is equal to 60 into 1 minus this cos of kt whole function is equal to minus 1. So that thing is equal to 60 into 2 there, and that is equal to 120 meter is the maximum height which he can attain in this height there, because it has the one cycle there. Now in the second part, when it completes one revolution in 30 minutes, show that k is equal to pi by 15. We know that in one cycle, it is going to make 360 degree, which is equal to 2 pi for one of that revolution there. So this means cos of kt should be equal to 1, because it is going to take 30 minutes. So we can write this thing as cos of 30k is equal to 1. or 30K is equal to cos inverse of 1, which is either equal to 0 degree, 0 radians or 2 pi radians. That is equal to 30K there. So K value is equal to 2 pi over 30, or that thing is equal to pi by 15, which we have to show in the second part, that it is going to make 1 cycle in 30 minutes there. In the third part, when its height is 90 meter above the ground, then you have to calculate the time for that factors there. So we know that h is equal to 60 into 1 minus cos of kt. This is the equation given to you. And when it is 90 meter above the ground, so height is taken to be equal to 90. That is equal to 60 into 1 minus cos of kt. But k value is equal to pi by 15, so we will take it later on there. So it should be equal to 90 over 60 is equal to 1 minus cos of kt, that is equal to 3 over 2 is equal to 1 minus cos of kt, or cos of kt is equal to 1 minus 3 over 2, that is minus 1 over 2 there. But we know that cos is negative in second and the third quadrant. And the second quadrant, you take the values pi minus theta and pi plus theta in the third quadrant of that. So it should be equal to, if we minus ignore it, let's say cos of kt is equal to half, then kt is equal to cos inverse of half, which is equal to pi by 3 radians. So in the second quadrant, its value will be equal to kt is equal to pi minus pi by 3 and pi plus pi by 3. So that thing is equal to 2 pi by 3 and 4 pi by 3. That is equal to kt. So kt is equal to 2 pi by 3 or 4 pi by 3. Then t is equal to 2 pi by 3 whole divided by k, or 4 pi by 3 whole divided by k. So that thing is equal to 2 pi by 3 into k value we have already calculated equal to pi by 15. So it should be equal to 15 over pi. So that is equal to 30 over 2. That is 10 minutes there. And if k value is equal to 4 pi over 3, then 4 pi over 3 into 15 over pi. So that thing is equal to 20 minutes there. So there are two timings for this. One is 20 minutes and one is 10 minutes there to make that one when it is at a height of 90 meter above the ground there. So these are the solution of this complete for the question number 6 there. No, question number 7 of this. The point C lies on the perpendicular bisector of the joining the points A, 4, 6 and B. C lies on this plane parallel to AB is 311. Find the equation of the perpendicular bisector of AB. Also calculate the coordinates of C there. So question number 8 now. It passes from the point A 4, 6 and B 10, 2. You have to find out the perpendicular bisector of AB. So let's say this is the line AB. Perpendicular means 90-degree angle and it is bisector there. So you are going to find out the equation of this line L there for this perpendicular to AB. So for this we will calculate the value of M first, that is equal to 2 minus 6 over 10 minus 4, that is equal to minus 4 over 6, or that is equal to minus 2 over 3. And the midpoint of AB is basically equal to 4 plus 10 over 2 and 6 plus 2 over 2. So that thing is equal to, the midpoint of that thing is equal to 14 over 2 is 7 and 6 plus 2, 8 over 2 is 4. So the midpoint of that thing is 7 and 4 there. Now you have to find out the equation of this perpendicular bisector of that. Because M is having this minus 2 over 3, so the slope of the line L is equal to, it is minus 2 over 3, so it is 3 over 2 there because it is perpendicular to that with the help of this property that M1 into M2 is equal to minus 1. Now you know the slope, you know the point from which it is passing, and we can find out the equation of this line L there. So equation of line L is going to be y minus y1 equal to M there is equal to 3 by 2 into x minus 7. This will become 2y minus 8 is equal to 3x minus 21, or 2y is equal to 3x minus 13. Let's say it is equation number 1 there. Then they ask in the second part that C is going to lie on this line parallel to AB. Let's say it is a parallel line and C is going to lie at this point which has the coordinate x, y there. But they are asking that this line is also passing from the point 11 and 3. So let's say this is the point which is going to be 11 and 3 there, which lies on this line there, AB, parallel to this. So the equation of this line parallel to AB, second part, parallel to AB and passing from this point 11 and 3 there. We know that it is parallel to AB, so the slope of this line and this line, that is equal there because they have the same slope there for the parallel lines. So the equation of line parallel to AB is passing from this point 11 and 3 means y minus y1 is equal to M, which is basically equal to minus 2 by 3 into x minus 11 there. This will become 3y minus 9 is equal to minus 2x plus 22. And this will become 3y is equal to minus 2x, 22 plus 9, 31. So that is the equation number 2. Because C is going to lie on this line there, which is the point of intersection of these two lines. So we can solve 1 and 2 there. So 1 is basically equal to 2y is equal to 3x minus 13, and equation number 2 is 3y is equal to minus 2x plus 31. So because we have to eliminate either x or y, so we are going to multiply this coefficient by 3 and this equation by 2 there. So equation number 1 will become 6y is equal to 9x minus 39, and equation 2 will become 6y is equal to minus 4x plus 62. So if we add these two, it is positive, negative. This negative will become positive. This positive will become negative. They are going to cancel each other. So 0 is equal to 13x minus since this is the line passing from this point 3 and 11 there. So we know this equation for this line parallel to AB and passing from this point 3 and 11. So y minus 11 is equal to, slope is the same because m has the same slope there, and that slope is minus 2 by 3 into x minus 3. So this will become 3y minus 33 is equal to minus 2x plus 6. This will become 3y is equal to minus 2x plus 39. Let's say that is equation number 2. Now we will solve 1 and 2 simultaneously to get the value of c there. So 1 is basically equal to 2y is equal to 3x minus 13, and 2 is basically equal to 3y is equal to minus 2x plus 39. Now we can multiply this by 3 and we can multiply this by 2 to eliminate y from these two equations. So this will become 6y is equal to 9x minus 39, and 6y is equal to minus 4x plus 78. So now we are going to subtract this equation 3 from this 4. So this positive sign will become negative, this negative will become positive, this positive will become negative. We are going to cancel, and that thing is equal to 13x minus, so 13x is equal to 117, and x is equal to 117 over 13, and that thing is equal to 9. So x value is equal to 9, and the y value will be equal to, we can put in any one of this equation, 2y is equal to 3x minus 13. So 2y is equal to 3 into 9 minus 13. So 27 minus 13, that is equal to, so y is equal to 14 over 2, that is 7 there. So you got the two values of x and y there, which is the coordinates of C, and that is equal to, x is equal to 9 and y is equal to 7 there. So that is the point of intersection of these two lines at the point C, which is parallel from that line which is having the coordinates 3 and 11, and it is parallel to the line slope AB there. So they have the point of intersection C, which is being calculated equal to 9 and 7 there. No, the next question is question number 8. The first, second, and the last term in arithmetic progressions are 56, 53, and minus 22. Find the sum of all the terms in this progression. Second, the first, second, and the third term of these geometric progressions are 2k plus 6, 2k, and k plus 2 respectively, where k is a positive constant. Find the value of k and find the sum of the infinity to that progressions there. No, because first, second, and the last term of an arithmetic progression is 56, 53, and minus 22. We know that for this arithmetic progression, an is equal to a plus n minus 1 into d. And you are going to find the sum of all these numbers there. And the sum formula there is Sn is equal to n over 2a plus n minus 1 into d, or n over 2 into a plus l. That is the sum of this when the last term is given to you. But they are asking that first term is 56. So a1 is equal to 56, a2 is equal to 53. And the difference d is basically equal to a2 minus a1. So 53 minus 56, that is equal to minus 3. And now you are going to find out the sum of this. But first, we will calculate the n number of terms there. And that can be used in the formula there, that an is equal to a plus n minus 1 into d, because this is also known as we call the last term of this portion there. So first we will calculate this last term is equal to minus 22. If we use this formula there, 1, then last term is minus 22, which is equivalent to a. A there is 56 plus n minus 1 as it is there into d, that value is equal to minus 3. So that is equal to minus 22 is equal to 56 minus 3n plus 3. Or minus 22 is equal to 56 plus 3 is 59 minus 3n. So 3n is equal to 59 plus 22. So 3n is equal to 81 and n is equal to 81 over 3, and that is equal to 27 there. So n is 27 there. A is known to you already, and we can now use the sum of this formula for the second term formula is used there. So sum to this 27 terms is equal to 27 over 2. The first term is 56 and the last term is minus 22. So that is equal to 27 over 2 into 6 minus 2 is 4, 5 minus 2 is 3. 2 is 17. So that sum of 27 term is equal to 27 into 17, and that thing is equal to 459. So this is the answer of this first part. Second part, that is in the geometric progression. So we know that for this geometric progression, it is ar square and so on. where R is basically equal to A2 divided by A1. So they have this geometric progression of these three terms. So it is also equal to A3 divided by A2 because they are the same things for the geometric progressions. So we can use it here. A2 is basically equal to 2K over A1, that is 2K plus 6, is equal to A3, that is K plus 2, over A2, that is equal to 2K. Now you can cross multiply. So 4K square is equal to K plus 2 into 2K plus 6, or 4K square is equal to 2K square plus 12 6K plus 4K plus 12. So that thing is equal to 4K square is equal to 2K square plus 10K plus 12. This thing is equal to 2K square minus 10K minus 12 equal to 0. Or K square minus 5K minus 6 is equal to 0. Then we can factorize this one. K square minus 6K plus K minus 6 is equal to 0. K is common. K minus 6 plus 1 is common. K minus 6 is equal to 0. K minus 6 into K plus 1 equal to 0. So K value is equal to 6 and minus 1. But minus 1 cannot be the value of that equation there. So this K value is minus 1, which is not possible because K is a positive constant there. So K value will be taken equal to 6 there. Now the two progressions are like this: 2 into 6, 12 plus 6, 18. If we put K value into this, then 2K, that is equal to 12, and then K plus 2, 6 plus 2 is 8. So these are the progressions in the geometric progressions of that. So R value is basically equal to 12 over 18, and that is equal to 2 by 3. So sum to infinity of this progression is A over 1 minus R. A is equal to 18 over 1 minus 2 by 3. That thing is equal to 18 over 3 minus 1, 2, 1 over 3. That is 18 into 3, and that is equal to 54. So this is the sum to infinity of this progression, which is given in this form there. Now we are solving the next question. This is question number 9, which is from the topic of the vectors, which is not in our syllabus. So we are going to start this question number 10. The equation of this curve is y is equal to 4 over 2x minus 1. First part, find showing by the all working the volume obtained of the region bounded by this curve. The x-axis and the line x is equal to 1 and x is equal to 2 is rotated about 360 degree about the x-axis. And the B part is given that the line 2y is equal to x plus c is a normal to this curve. Find the possible values of the constant c there. So question number 10. Y equal to 4 over 2x minus 1 is the equation of this curve. And you are going to find out the volume when it is rotated from x is equal to 1, 2x is equal to 2, about 360 degree, about x-axis there. We know that the volume formula is equal to pi y square d of x, and the limits are a to b there. So we can write this one, v1 is equal to pi, the limits are 1 to 2, y square is 16, because if y is equal to 4 over 2x minus 1, then y square is equal to 16 over 2x minus 1 whole square into d of x. So this is pi into 16 into 2x power minus 2 d of x, and the limits is 1 to 2 there. So this will be equal to pi, 16 is constant, so it will be taken outside of that function. The integration of this one is 2x minus 1 power minus 1 over minus 1 into the integration of this one is 2 there, and the limits are 1 to 2. So this will become minus 8 pi into 2x minus 1, and the limits is 1 to 2 there, which is equivalent to minus 8 pi over 2x minus 1, and the limits is 1 to 2 there. Now we put the limits on it. So minus 8 pi as it is 1 over 2 into 2 minus 1 minus 1 over 2 into minus 1 into minus 1. So that will be equal to minus 8 pi, 1 over 4 minus 1 is 3, minus 2 minus 1 is 1. So that is minus 8 pi. This is minus 2 over 3. So that thing is equal to positive 8 2s are 16 pi over 3, because they are asking the volume there. So it is cubic unit of this there, which is due to the x-axis of this equation. Y is equal to 4 over 2x minus 1 whole. So the second part of that thing is they are asking about the normal to this curve is given by 2y is equal to x plus c, and you are going to find out the values of possible values of c there. Since y is equal to 4 over 2x minus 1, so we will first find the dy by dx for this portion. So when y is equal to 4 into 2x minus 1 power minus 1, then we can find out dy by dx is equal to 4 as it is minus 1 into 2x minus 1 power minus 2 into 2. So that is going to be equivalent to minus 4 2s are 8 over 2x minus 1 whole square. That is the value of m, and that is dy by dx. But the standard equation is given there. 2y is equal to x plus c. So if 2y is equal to x plus c, then y is equal to half x plus c over 2. So the slope of this line is half there. Since they are asking about the normal to this curve, so the slope of normal will be equal to minus 2, because it is a reciprocal of half there with a negative sign of that portion. Now, we know that the slope is given there minus 8 over 2x minus 1 whole square is equal to minus 2. So minus and minus plus there. 2 ones are 2, 2 fours are 8. So we can write this thing as 2x minus 1 whole square equal to 4 there, or 2x minus 1 is equal to plus minus 2 there. So 2x is equal to 1 plus minus 2, or that thing is equal to 3 and minus 1. Our x value is equal to 3 over 2 and minus 1 over 2. So we can find out the value of c when x is given there. So y values is equal to 4 over 2x minus 1. So we put y equal to 4 over 2 into 3 over 2 minus 1. So that is equal to 4 over 3 minus 1 is 2 there. So that is 2. So the point there is y is 2 there and x is 3 by 2. So y equal to 2y equal to x plus c. So 2y value is there 2 equal to x value is 3 by 2 plus c. So c value is equal to 4 minus 3 by 2 or 8 minus 3, 5 over 2. So one value of possible c there is 5 over 2 there. Now we put the second value of x, that is minus half. So y is equal to, when x is minus half there, 4 over 2 into minus half minus 1. So that thing is equal to 4 over minus 2, and that value is equal to minus 2 there. So the point is there minus half and minus 2. Now we put in this main equation there 2y is equal to x plus c. So 2 into minus 2 is equal to x value is minus half plus c. So minus 4 plus half is equal to c there. So minus 8 plus 1 minus 7 over 2 is equal to c there. So that is the second possible value of c, which is minus 7 over 2 there. So there are two possible values of c. One is 5 over 2 and one is minus 7 over 2. Now we are starting the last question of this, which is question number 11. The function f is defined for this f of x is equal to 2x square minus 6x plus 5, where x belongs to the real numbers. Find the set of the values of p for which the function f of x is equal to p has no real roots. So 2x square minus 6x plus 5. So it has no real roots. That means b square minus 4ac is less than 0. So it will become 2x square minus 6x plus 5 minus p equal to 0. b is a is to b is minus 6 and c value is 5 minus p. So b square is minus 6 square minus 4 into 2 into 5 minus p, and that is less than 0. So that is 36 minus 8 into 5 minus p is less than 0, or 36 minus 40 plus 8p is less than 0, or 8p plus minus 4 is less than 0, or 8p is less than 4, or p is less than 4 over 8. This implies that p is less than half. This is the possible values of p from this equation there. So g of x is range is from 0 to 4, and we have to express it in the form of x plus g p whole square plus c. So g of x is equal to 2 is taken common. It should be equal to x square minus 3x plus 5 over 2. This thing will be equal to 2. Now we can use the completing square for this. So it is a square minus 2 into b. So b is 3. So that is, it will become 3 over 2, because we know that a minus b or a plus b whole square is equal to a square minus 2ab plus b square, and it will be plus here. So it is minus, so we are going to use the minus formula there. Plus 3 over 2 whole square, because that is the value of b. So it is added and it is subtracted at the same time, plus 5 over 2 there. So this is going to be equivalent to 2 into, up till here, it is x minus 3 over 2 whole square minus 9 over 4 plus 5 over 2. So that thing is equal to 2 into x minus 3 over 2 whole square plus 5 over 2 minus 9 over 4. So that thing is equal to 2 into x minus 3 over 2 whole square plus, if 4 is LCM, 5 to the 10 minus 9, 1 over 4 there. So that thing is equal to 2 into x minus 3 over 2 whole square plus 1 over 2. If we compare it with this standard equation of this, in which we have to convert it, so a value is 2 there, b value is basically equal to minus 3 over 2, and c value is equal to half. Now they are asking that what is the range of this. So if you put 0 in it, so its value is 2 into this plus half.